All right, welcome to this explainer. Today we're tackling a super practical, everyday dilemma that's probably going to affect you the very next time you pull up to the gas station. We're looking at exactly what happens inside your standard EO gasoline engine, whether that's your daily commuter car or your absolute favorite motorbike, when you go ahead and fill it up with an E20 ethanol blend. So you're seeing E20 fuel popping up literally everywhere at the pumps these days, right? It's a blend of 20% ethanol and 80% gasoline. But if you pop open the glove box, your car or motorcycle's manual probably explicitly says E0, which means 100% pure gasoline. So what's the actual science here? What happens when you cross the streams? Will running E20 in an engine specifically designed for E0 actually ruin it? Or is that just some urban myth? To figure this out, we're looking at some incredibly cool research from the Symbiosis Institute of Technology. Now, these researchers, they didn't just guess. They literally strapped high-tech pressure and temperature sensors onto a 1.2-liter naturally aspirated engine. That's a super common engine size for a standard compact car, by the way. And by hooking it up to a high-speed data acquisition system, they managed to map the exact cause and effect journey of the fuel, literally, frame by frame, explosion by explosion. Okay, moving right into section 1, the chemistry, a tale of two fuels. To really understand what your engine is feeling, we first have to realize that ethanol is fundamentally different from pure gasoline on a molecular level. You aren't just putting in a different brand of gas. You're introducing a totally different chemical compound into your vehicle's ecosystem. Think of pure gasoline as a super dense, high-calorie meal, while ethanol is, well, it's more like a high-volume, low-calorie energy drink. Pure gasoline heavily wins out on what we call heating value. That's the raw thermal energy stored inside it. But ethanol? It actually wins on octane rating, and crucially, it comes packed with its own extra oxygen atoms. And this right here perfectly illustrates the immediate hurdle. Ethanol has a heating value of 26.8 megajoules per kilogram. Compare that to gasoline's massive 42.8. Because of that much lower heating value, your car or motorbike's engine actually has to drink a significantly larger volume of E20 fuel just to produce the exact same amount of mechanical work as pure gasoline. Your fuel injectors essentially have to work overtime just to keep the engine happy. Which brings us to section 2, the performance boost, low and medium speeds. The really critical question here is what happens when that oxygen-rich, higher volume E20 actually hits the combustion chamber at everyday driving speeds? You know, when you're just cruising through city streets or navigating suburban traffic. Surprisingly, at these low and medium speeds, E20 actually gives your engine a bit of a performance boost. Ethanol's extra oxygen and its high laminar flame speed, which basically just means how fast the fire actually spreads, acts exactly like that energy drink we mentioned earlier. It causes the fuel to burn faster and more completely, creating a higher peak pressure inside the cylinder. It literally translates to a more forceful push on the pistons. And the hard data totally backs this up. The researchers found that switching to E20 at low and medium speeds actually bumped up the peak cylinder pressure by nearly 18%. And the heat release rate shot up by as much as 13%. So if you're stuck in stop-and-go traffic, your older E0 engine might actually feel, a little bit snappier and more responsive on E20. Let's look at section 3, the drop-off, high-speed struggles. Because as you might guess, this honeymoon phase doesn't last forever. What happens when you push that engine to its absolute limits? Say you're merging onto a fast-moving highway or revving your motorbike right up to the red line. As you accelerate to high speeds around 6,000 RPM, the trend completely flips, and pure gasoline reclaims the throne. Why? Well, ethanol takes a lot longer to evaporate than gasoline. At 6,000 RPM, the engine is moving so incredibly fast that the fuel is just flooding in rapidly. The ethanol simply doesn't have the time to evaporate properly, which actually slows down the combustion process exactly when you need it to be the absolute fastest. E0 gasoline, with its superior volatility, easily outperforms E20 at those high speeds. All right, section 4, the trade-offs, your wallet and the fuel gauge. We've seen the power dynamics under the hood, that low-speed boost and the high-speed drop-off. But let's slow down for a second and look at the actual everyday cost to your wallet and your fuel gauge. To understand why your mileage drops, engineers use a specific term called brake-specific fuel consumption, or BSFC. In plain English, this is basically a measure of your engine's fuel efficiency. It's the rate at which your engine eats fuel to give you a specific, constant amount of power. The research is crystal clear on this. Because you're burning fuel with a lower energy density, your engine's fuel consumption measurably increases with E20. Just to maintain the exact same power output and speed you're completely used to with E0, your car or bike just has to drink more E20. So even if E20 is slightly cheaper per gallon at the pump, you might find yourself getting on a first-name basis with your local gas station attendant, because you'll absolutely be filling up more frequently. Moving on to Section 5, Long-Term Impacts. The harsh reality of compatibility. Beyond just the immediate math of mileage and power curves, we've got to talk about the long-term impacts of running E20 in a car or motorcycle engine strictly designed for E0. This is where the physics and chemistry really start to work against your vehicle's hardware. Let's start with how you actually store your vehicle. Ethanol inherently attracts moisture from the air. If E20 fuel sits in your motorcycle's gas tank or your car's fuel lines for a few weeks, it can undergo something called phase separation. This basically means the fuel separates, creating this highly corrosive watery alcohol mixture that sinks right to the bottom of the tank. And if you start your engine and it sucks at that water phase, man, be warned, it can cause serious, immediate internal engine damage. Then we have the dreaded cold start problem. Ethanol has a higher heat of vaporization and a lower reed vapor pressure than gasoline. Practically speaking, this just means ethanol is way harder to turn into a combustible gas. So, on a chilly morning, while you're sitting in the driver's seat shivering, your older E0 engine is likely going to seriously struggle to start on E20. The fuel-air mixture will simply be too lean to catch fire easily, leading to lots of frustrating cranking before the engine finally turns over. But honestly, the most serious advisory from the researchers is all about material compatibility. Ethanol is highly corrosive. If your car or bike was manufactured before ethanol blends became the standard, its fuel system was built for gasoline, not alcohol. Over time, E20 can quietly degrade and melt your rubber seals, dissolve the plastics, and actively corrode the steel and aluminum parts within an older E0 fuel system. That leads to costly leaks and repairs practically out of nowhere. Okay, finally, Section 6, the final verdict, weighing the pros and cons. Let's step back and weigh all these complex factors to give you the final verdict on running E20 in your standard gasoline engine. It's totally a game of trade-offs. On the plus side, E20 offers some undeniable environmental benefits. It's derived from zero-emission biomass production, and it definitely burns cleaner. Plus, as we saw, it actually provides a genuinely interesting low-speed combustion boost. But, the cons are pretty heavy. The trade-offs in lower fuel economy, those super frustrating cold morning starting difficulties, and the severe kind of hidden corrosion risks to your rubber seals and fuel lines, they are substantial for unmodified engines. This explainer leaves us with one critical thought to ponder the next time you're standing there holding the fuel pump nozzle deciding what to put into your ride. E20 undeniably offers a greener world and cleaner emissions, but is your older E0 designed car or motorbike truly ready to pay the mechanical price? Thanks so much for joining me for this explainer, and I will catch you next time as we break down another fascinating topic.